there, it's Christina from the Glaser Tutoring Company, and today we're going to be solving a system of equations using any method that we want, but we got fractions. Ooh, all right. So first off, right, we have a system of equations. We have two or more equations, so that's part of the system. Now, in this case, all we have to do is just solve for this system. But what does that mean? Well, we got x values here, only raised to the first. We got y values here, only raised to the first. There's no x value that, has a squared in it, no y value that's a cubed. So for x is raised to the first and y is raised to the first, these are linear or straight lines. So the solution lies in the point that they intersect. Now, I don't know if they intersect. These might actually be the same line. They might be parallel to each other, which means that they will never intersect. But we're going to try to solve. And we're going to try to solve for that point that they cross paths, right? That they have some type of interaction with. And if we are trying to solve just for a point, I know that we're just trying to solve for an x and a y value. So we're basically solving for these x's and these y's. Now, there's a couple of ways to solve systems of equations. You have substitution, you got addition, right? If you classify the addition method as adding, you got the elimination method is when you're subtracting. So there's many different ways. And, for doing the addition method here, elimination or substitution, you would get the same answer. But we always just do one that's easy for us, right? The first thing that I always like to do is see if I could substitute. Now, normally, you only want to substitute if you do see that you have an x value all by itself, like this guy, right? There's no, this is just 1x. This is not a 2x or a 3x. So under normal circumstances, I would try to use my substitution method. However, here, I don't want to substitute with all these fractions. So maybe, for me, I don't really want to do substitution because I don't want to substitute all of these fractions into the other equation. So maybe what I'll do is I'll try to eliminate one of the other fractions or the other variables, right? So what I see here is I see that the denominators for the top function, the linear line, is a 12, and the denominators for the other fraction is a 2. Maybe I could turn the 2 into a 12, right? Maybe I could turn this 5 over 2 into 5 over 12. That might be something, because if I could do that, then I can eliminate this one fraction, and everything would be nice. Now, let's see if I could do that. Now, I like to multiply. I don't like to divide, so I like to go up in value. So I'm going to take this 2, and I'm going to try to get to the 12. Now, let's just analyze, right? We want to make this number into this number. Don't even worry about the signs. That comes next. I just want to try to match the 5 over 2 into the 5 over 12. Now, I know that I'm going to have to multiply by some type of fraction. Let's start with the numerator. Now, I have a 5, and I want to stay at a 5. So 5 times what will get me a 5? Yeah, you got it. It's a 1, right? So my numerator has to be a 1. And now let's work on the denominators, right? 2 times what will get me 12? Yeah, 2 times 6. So I know that I'm going to have to times everything by 1/6 to get these fractions the same, and then I can get rid of them. But now you just got to be fair. If you're multiplying the 1/6 by the 5 over 2 to get this value, you gotta do it for everyone. So that's the name of the game. So let's try it out, right? We have this, we'll say that this linear line is going to be the same. So we have x minus 5/12, and that's the y value, equals negative 55 over 12. And now let's do the other one, right? So we have negative 6 times 1/6, right? If we have negative 6 times 1 over 6, the 6's cancel out. So basically, you just are left with that negative value. So this would be a negative x. You could say negative 1x if you want, but it's a negative x. And now we know that the 1/6 times the 5/2 is going to be that 5/12. It's a positive value because this was positive, and that's the y. And now, let's see, here we have 1/6 times 55/2. So 1 times 55 is just 55. 6 times 2 is 12. And it's a positive value. This was positive. So we have our two formulas. Okay. Now, let's try to eliminate one of them. Now, in this case, it turns out that, look at this, right? We could even do x minus x, right? Because these are the same values. And these are the same values. They're just opposite. So when you have opposite signs, you will add your two equations together. So if you have one x positive and the other x that's negative, you will add the two together. And that's how they will cancel. So in this case, we're going to add these together. But then this is interesting because x plus a negative x, that goes bye-bye. You lose that variable. Negative 5/12y plus positive, right? 5/12y, that goes bye-bye. You have nothing on the left side. And I just rhymed, right? You got no more y on this side. They go bye-bye. Whoo! I think I'm losing it, but don't worry. So this is just a big fat 0 on this side. And now these numbers are the same, but opposite as well, right? So negative plus a positive, 55/12, that's a 0 as well. Ooh. All right, so we're down to it, right? Now, when you lose your variables, so we'll say we lost both variables. Now, when you lose your variables, guys, this could be two possibilities. Either these two equations are the same equation, which means that they are literally identical. And if they are right over one top of each other, that means that they will have infinite lines, or not lines, but infinite points that they all share. Or they might be parallel to each other, in which they have no solutions. So which one is it? Well, it all comes down to the mathematical statement. Does this mathematical statement make sense? 0 equals 0. I would say yes. That's a big fat check. In order for it not to make sense, it would be like 0 equals 3, where obviously 0 doesn't equal 3 and 3 doesn't equal 0. So if this makes sense, that means that these are the same line. And if they are the same line, just like I drew a little while ago, that means that every single point that they have is the solution. So we call that an infinite amount of solutions, meaning that there's actually no quantifiable value because literally every point would be a solution. So every means infinite. And that is the answer for this. What'd you think? I hope this helped. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel, like the video, tell your friends, tell your classmates. We just want to get the word out there that this channel exists and help as many students as possible. So thank you so much for the support thus far. You guys rock. Also, I would like to give a huge shout out to Maricela. Thank you so much for being a member to the channel. Your support means a lot to my brother and me, and we're thrilled to have you be a part of this amazing community. Memberships are open on the channel, and if you want to become a member, just click that join button, which can be found below on any video if you're watching on your desktop, or it can be found on the overall channel page too. For all of you that want your name shown in the video, don't forget to choose the gold tier or higher. Thank you so much for considering, and have a great day. Talk to you in the next lesson. Bye-bye!